All right, welcome everybody. This is part one of lesson 4 in our geometry unit. Today we are going to be working with the Pythagorean theorem. So our objectives are prove the Pythagorean theorem and then use the theorem to find the missing sides of a triangle. So we're starting out with some real simple class notes. The Pythagorean theorem, it's for any right triangle. So this will only work for right triangles, which means a triangle that has one 90-degree angle in it. So if we look at this triangle here, here's our 90-degree angle. And the way the theorem works is that the sides of the triangle that come together to make the right angle, so side A and side B, if we square those two sides and then add them together, they will be equal to the square of side C, which is the hypotenuse. Okay, so where C is the length of the hypotenuse. And this works for any right triangle. Doesn't matter how big or how small the right triangle is. So let's do this exercise. Let's put putting Pythagoras to work. Let's find x for each of these. So if we look at this first one, we have a right triangle with sides of length 4, 3, and then x. So let's find x. So we know that 3 squared plus 4 squared will equal x squared. 3 squared is 9, 4 squared is 16, so it's a total of 25. So we're looking at 25 is equal to x squared. Now all we have to do is take the square root of both x squared and 25, and we see that 5 is equal to x. Do the same thing for the next example. We've got sides 8 and 6, so we're going to do 6 squared plus 8 squared equals x squared. 6 squared is 36, 8 squared is 64, so we're looking at a total of 100, and that's equal to x squared. And then we take the square root of 100 and x squared, and we get 10 is equal to x. Then we can do this here. We've got a right triangle with sides 12, 9, and x. So we're going to take 9 squared plus 12 squared. It's going to be equal to x squared. So 9 squared is 81, 12 squared is 144. Add those together. We get 225 is equal to x squared. Take the square root of both 225 and x squared, and 15 would be equal to x. Now, one thing I want you to notice is that in any right triangle, because this is a pattern, right? Any right triangle, we have these sides, 4, 3, 8, 6, 12, 9. What do you notice about the hypotenuse length? The hypotenuse length is always longer than any of the two sides. It is the longest part, the longest side of a right triangle. Let's try this last one. 16 and 12, so we've got 12 squared plus 16 squared equals x squared. Add the squares of those together, and we get 400 is equal to x squared. Take the square root of 400, square root of x squared, we get 20 is equal to x. So again, we want to always look for patterns in mathematics. Patterns are always a good sign that something is consistent. It's going to happen over and over again. So here we have this question. Is there a pattern emerging? How are the sides of these triangles related to the base? So notice like this one, 3, 4, 5 triangle. Okay? So what we're looking at is that we have multiples of 3, 4, 5 are all Pythagorean triples, all Pythagorean, oops, sorry, that should be an O, Pythagorean triples, and form right triangles, okay, or right angles. Right angles. All right, so you can see that here. Again, 3, 4x. What do we have? We've got 3, 4, 5. We've got 6, 8, 10, right? Multiples, and that's basically this triangle. Multiply it with everything multiplied by 2. 9, 12, 15. 12, 16, 20, right? So 3, 4, 5. 3, 4, 5. And that is a pattern that we notice with all right triangles.